today I'm going to be going over a couple more segmented angle proofs so you can see more examples of these. So here's the first one, and I tell you that AC equals AB plus AB. So our first statement is given. Our next one, I tell you that AC equals AB plus BC. Well, let's look at the picture if I can find anything out. AC is the whole thing, and AB plus BC are the parts, and part plus part equals whole is our segment addition postulate. Next, I have AB plus AB equals AB plus BC. Now, if we notice, these two statements are exactly the same, but these have changed. And if I look at the line above it, AC equals AB plus AB, so I can substitute in the AC for AB plus AB, so that is substitution. Property of equality. Okay. And now our next one, if we notice, we subtract AB on both sides, and we're left over with AB equals BC. So this is our subtraction property of equality. All right, let's look at another one. My first one is my given. M is the midpoint of line segment AB, so that's my given. And then if I use that statement, that means AM is congruent to MB, which is right here, so this is our definition of midpoint. Next, if I look at the one above, I can go from congruency to equality, and that's our definition of segment congruence. Then I have AM plus MB equals AB. Well, let's see on our picture what we can get from that. I have AM plus MB, which are parts, equals AB. So that's part plus part equals whole. So that's our segment addition postulate. All right. Next up, I have AM plus AM equals AB. Well, these two are the same, and these two are the same. But MB and AM have been changed. And the line above it tells us that AM equals MB. So we could substitute in AM for MB, and we get our substitution property of equality. Okay, next up, I have 2AM equals AB. Well, we combined our like terms. We added the two AMs together, but it was only on one side, so it's combining like terms. And when we combine like terms, that is called simplify. So we simplified. When we just combine like terms, it's simplified. And the very last one is AM equals 1/2 AB. Well, we divided to get the AM by itself by 2 on both sides, so that is a division property of equality. So we had a few different ones we haven't really seen before yet, especially the simplify. All right, let's do another one. This one, I tell you that 5 and 6 are congruent, so that is our given. And then I say a measure of angle 5 equals the measure of angle 6. Well, I notice that the congruency changed to equality, and that's our definition of angle congruence. Okay. Next up, I tell you that the measure of angle RUN is equal to the measure of angle 5 plus the measure of angle 6. Well, let's check our picture. RUN is equal to 5 plus 6, which is part plus part equals whole, which is true. And that's our angle addition postulate. Next, I notice that these two are the same, these two are the same, but our 6 and our 5 have changed. And I notice on the line above that 5 is equal to 6, so I can substitute in 5 for 6. So that is our substitution property of equality. Okay. Next up, I have the measure of RUN equals 2 times the measure of 5. Well, if you notice, we have combined our like terms, and when we combine like terms, that is simplify. Next up, I notice that my statement has been flipped, and when I flip a statement, that is symmetric. So this is our symmetric property of equality. Next, I notice that the measure of angle 5 has been isolated, so that means I divide it to get rid of that 2. And so this is the division property of equality. Okay. Our next one, O is the midpoint of line segment TY. That is our given. And whenever I have a midpoint, I always like to go up here. O is the midpoint, so that means TO is congruent to OY, which is this statement right here. So that's our definition of midpoint. Always use your given if you can. Next, I notice that we move from congruency to equality, and that's our definition of segment congruence. Our next statement says TO plus OY equals TY. Well, let's look at the picture to see if that helps us. TO plus OY equals TY. Well, that's a part plus part equals whole, so that's our segment addition postulate. All right, next I notice that the TOs are the same and the TYs are the same. But what's different is the OY and the TO. And if I look at the line above, TO is equal to OY, so I substitute in the TO for the OY, so it's substitution property of equality. Next, I notice that I combined my like terms. I added the TOs together, so that is simplify. And the very last one, I divided by 2 on both sides, so that is our division property of equality. I have one last example for you guys to see. Okay, first one, I tell you that line segment AB is congruent to line segment BC. That is given. Next, I notice that the congruency moved to equality. That's our definition of segment congruence. Next, I have AC is equal to AB plus BC. Well, let's look at our picture. AC is the whole thing, equals AB plus BC. Well, that's part plus part equals whole, so that's our segment addition postulate. Next, I notice that AC is the same, and AB is the same, but BC and AB have changed, and the line above it, AB is equal to BC, so I substitute in the AB for BC, and that substitution property of equality. Next, I notice that I combine like terms. I added those ABs together to get 2AB, so that's simplify. And then I divided by 2. So that's our division property of equality. The very last one, I notice that my statement has been flipped, and that is symmetric property of equality.